Today we're going to get into multiplying and dividing exponents. These are some of the basic rules for multiplying these are some of the basic rules for exponents. For multiplying, you need to add. And to divide, you need to subtract. But this only applies to the exponents. Keep in mind, any coefficients, you would still multiply or divide them just like you would in any other problem. For multiplying, let's take a to the fifth times a squared. As long as the bases are the same, and the bases are these a's, we're going to take and add the exponents. So this is going to be a to the 5 plus 2, which gives us a to the 7. Note that we didn't have any coefficients, so there's nothing to multiply there. Now, if we add coefficients, those are still just numbers. They're not exponents, so we don't add them. We still would multiply them just like we would any number. So 3 times 4 is going to give us 12. The base is still the same, so we have that. 2 plus 5 is x to the 7. The main thing here is to remember that you multiply the coefficients and add the exponents. A common mistake is to either add everything or to multiply everything. Now, if you have different bases, so let's take x squared times y to the third. Since the bases are not the same, these exponents cannot combine in any way. The only thing that we can do to simplify this is to push them together, basically eliminating the dot that says to multiply. And by putting them next to each other, that means the same thing as multiplying. Now, if we had coefficients in front, the coefficient wouldn't just stay in front of the x, it would just go in front of the whole entire thing. So we'd still put the two together, the x squared and the y cubed, but the coefficient would be out front. So that 3 is multiplying to everything, since all of these are just multiplied by each other. If we had coefficients for each one, it wouldn't change anything. We'd still multiply the coefficients, so we'd have 12, and we'd have x to the fourth, y squared. That puts everything together there. Note that the 12's out in front. If we wanted to rewrite this, we could also put it as 12 times x to the fourth times y squared. This 3 doesn't necessarily belong to that y squared. It would just be multiplied. Now to divide. Division just is subtraction. So if we were to have x to the 7th over x squared, the easiest way to do this is take the biggest exponent minus the smallest one, and whatever you have left over is going to go wherever the biggest one came from, in this case the top. So this would be 7 minus 2 gives us 5, so we have x to the 5th. And keep in mind, anytime you have a whole number, it just represents something that we would have on top. If these were reversed, and we had the bigger number on the bottom, we would still do 6 minus 3, giving us a positive. The difference is our remainder would have to go on the bottom. So we had to have x to the third on the bottom of a fraction. But we can't just have x to the third. We need to have a 1 on top of it. So it'd be 1 over x to the third. Same rules apply with coefficients. If you have coefficients in front of them, these have to get divided, not subtracted. These are not exponents. So what we're left with is 10 over 5, which gives us 2, 5 minus 2, which is x to the third. And all of that is on the top of a fraction, so we don't actually need the fraction. Now, with the 10 over 5 and the coefficients, it's important to think of this in terms of simplifying or reducing the fraction as opposed to division, because you're not always going to get a whole number. You may end up with something like this, where we can't reduce this down to a whole number. But what we end up doing is reducing the fraction down. 6 goes into 6 one time and into 18 3 times, so we need the 3 on the bottom. 2 minus 1 would leave us 1x. There's more x's on top, so our answer would be x over 3.